Java continues to be one of the most widely used and versatile programming languages in the world. Known for its platform independence, object-oriented principles, and robust ecosystems, Java has become a core skill for software developers and especially for those who are building enterprise-level applications, web platforms, and mobile apps. Because of its relevance across industries, Java frequently features as primary subject in technical interviews. Whether you're applying for a role as a software developer, backend engineer, or even full-stack professional, a strong command of Java fundamentals and advanced concepts is essential to stand out. In interviews, Java questions are often designed to test not only your theoretical knowledge, but also your ability to apply concepts in real-world problem solving. Recruiters and technical panels look for clarity in understanding core principles like object-oriented programming, which is OOP, collections, multi-threading, exception handling, and design patterns, as well as more advanced areas such as JVM interns, concurrency, and performance optimization. To help you prepare thoroughly, this guide presents 30 carefully selected Java interview questions and answer divided into 3 levels. The first one being beginner level, which covers basic concepts like syntax, data types, OOP principles, and control structures. Next, we'll be moving on to intermediate level, which focuses on collections, exception handling, file handling, and commonly used Java libraries. And finally, we have the advanced level, which explores JVM architecture, multi-threading memory, design patterns, and best practices. By practicing these questions, you'll not only strengthen your technical foundation, but also gain confidence in articulating your answers effectively during interviews. Whether you're just starting your Java journey or aiming for senior roles, this comprehensive set will serve you valuable resources for mastering interview preparation. Before we commence, if you're ready to take your developmental skills to next level, our Microsoft AI-powered full-stack development program is designed to make you job-ready in just 9 months. This AI-powered full-stack development program is designed for professionals aiming to build and optimize modern web applications. Gains hands-on expertise in AI-powered front-end and back-end development, database management, API security testing, development, and more. Learn through 100+ hours of core curriculum delivered in live online classes by industry experts. Enhance your coding skills using AI-driven tools like ChatGPT, Code Whispers, Copilot, and Hugging Faces. Work on 3 capstones from various industry and 60+ hands-on projects. Develop interactive website with React, HTML, CSS, and JavaScript. Build scalable web applications using MongoDB, Express.js, and Node.js. Build a Git portfolio to showcase your skills in creating dynamic web apps. 15+ skills covered: front-end development, back-end development, version control, and collaborations. Now, are you ready to build your future? Enroll now and take the first steps towards becoming a Microsoft certified AI-powered full-stack developer. The course link is provided in the description below and in the pinned comments. Before moving forward, I request you guys to do not forget to hit the subscribe button and click on the bell icon so you don't miss any further updates from Simplilearn. So let's get started. So let's start with the beginner level questions. First one is, what is Java and why is it a platform independent? Java is a high-level object-oriented programming language created by Sun Microsystem in 1995, and now it's owned by Oracle. One of its most important features is its platform independence, which means you can write a Java program once and run it anywhere. This is possible because Java code is not compiled directly into the machine code. Instead, it is first compiled into bytecode, an intermediate representation. This bytecode runs onto Java Virtual Machine, which is JVM, which acts as an interpreter between the code and the underlying operation system. Since JVM are available for Windows, Mac OS, Linux, and even mobile platforms like Android, the same Java program can run without any changes. For example, a banking application written in Java can work across different operating systems seamlessly, making Java the preferred choice for enterprise-level applications. So let's move on to the second question, that is, what are the main features of Java? Java offers several features that makes it powerful and popular. The first one being object-oriented. Everything in Java revolves under objects and classes, encouraging modular and reusable code. Second one is platform independent. Java bytecode runs on any system with a JVM. Third one is robust and secure. Built-in memory management, garbage collection, and strong type checking reduce bugs and security risks. And the next one is multi-threaded, which supports concurrent execution of tasks, improving efficiency in real-world applications like servers and games. For example, developers building an e-commerce application can use Java's collection framework for data handling, JDBC for database interaction, and services for web requests. Combined, these features allow for scalable, secure, and reliable applications that run across multiple platforms. So the next question is, what is the difference between JDK, JRE, and JVM? JDK is Java Development Kit, a complete development kit containing JRE plus development tools like Java compiler, debugger, and documentation generator. It is required to write, compile, and debug Java programs, whereas JRE is Java Runtime Environment. This provides only the environment to run Java applications. It includes the JVM and core libraries but no developmental tools. Next is JVM. JVM is Java Virtual Machine. This is the engine that executes Java bytecode. It handles memory management, garbage collection, and security. Think of it this way. If you are a developer, you need the JDK to write and test your code. If you are a user just running a Java application, the JRE is enough. The JVM works under both JDK and JRE to execute the bytecode on the host machine. Next question is, what are the four main principles of OOP in Java? The four main pillars of object-oriented programming are encapsulation, which is wrapping the data and code into single unit. For example, if you're using a private field and public getters or setters. Second one is inheritance, which is reusing the code by creating a new class from the existing one. For example, a car class inherited from vehicle class. The next one is polymorphism, which is performing a single action in different ways. For example, method overloading or overriding. Next, we have abstraction, which is hiding implementation details and exposing only essential features achieved using abstract classes and interfaces. These principles make Java code modular, maintainable, and reusable. For instance, in a payroll system, you can define a general employee class and create subclasses like manager or intern that inherit properties and behaviors. We'll move on to the next question, which is, what is the difference between is equal to symbol and dot equals in Java? Equals to operator compares memory references, that is whether two variables point to the same object in the memory. Whereas dot equals method compares the content of the objects. For example, if you have a string s1 is equal to new and the string is hello, string 2 is equal to new, which is string hello in double colon, whereas system.out.print s1 equals s2 is a true statement which is the same content. In interviews, remember that is equal to operator is the best for primitives, which is integer, character, etc., while dot equals is the best for objects like string. The next question is, what are Java data types? Java has two categories of data types. One is primitive data types, which are basic building blocks such as int, byte, character, float, double, long, short, and boolean. They store raw values. Example, int age is equal to 25. And the second type is non-primitive, which is referral data types. These include string, arrays, classes, interfaces. They store references, which is like address to objects, not the actual data. For example, if you have a string name is equal to Java, using the right data type ensures efficient memory usage for better performance. For example, if you only need true or false values, using boolean instead of a string saves space and speeds up the execution. Now the next question is, what constructor in Java is? A construction is a special method used to initialize objects in Java. It has same name as the class and does not have return type. When an object is created using new keyword, the constructor is called automatically. For example, if you have a class named student, where string name and student string n is given, we have a constructor inside it which is name is equal to n. And also we have student s1 is equal to new student Alex. Now here constructor can be default parameters or even overloaded. They are widely used to set initial values for objects, ensuring consistency and avoiding uninitialized variables. The next question is, what is method overloading? Method overloading means defining multiple methods with the same name but different parameters list, which is numbers, types, or orders, or even any kind of parameters. It is a type of compile time polymorphism. Example, if you have a class called calculator and given the parameters which is int add, we're returning a plus b. So here we have double add, double a comma double b are the parameters passed through it, which also returns a plus b. Here the add method is overloaded. Method overloading makes code more readable and reusable, as you can see the same method name for different input scenarios. The next question is, what is the difference between while and do-while loops? While loops checks the condition first, then executes the body. If the condition is false at the beginning, the loop won't run at all. Whereas in do-while loop, it executes the body at least once before checking the condition. For example, if you have int x is equal to 0 and you have a while loop which is x is greater than 0 and you give it, the print statement won't run. And whereas in do-while loop we have system.out.println x while x is equal to greater than 0, it runs at least once. In practice, while is used when a number of iteration is unknown and do-while is useful when the loop must execute at least once. Example, if a menu-driven programs. So the next question here is, what are access modifiers in Java? Access modifiers define scope and visibility, classes, methods, and variables. For instance, we have public, which is accessible from anywhere. And then we have protected, which is accessible within the same package and subclasses. Then we have default, which is no modifier, accessible only within the same package. And then we have private, which is accessible only within the class. For example, marking fields as private and exposing them through public getters or setters ensures encapsulation. Using modifiers effectively improves security, modularity, and maintainability of code. Next, we'll be moving on to intermediate level of Java questions. Here, the first question is, what are Java collection? Java Collection Framework, which is JCF, is a set of classes and interfaces that provide ready-made data structures and algorithms to store, retrieve, and manipulate groups of objects. Instead of writing your own linked list, hash tables, or queues, Java provides these implementation out of the box. Some commonly used interfaces include lists, sets, queues, and map. Their implementation are classes like ArrayList, HashSet, priority queue, and HashMap. The collection framework also offers utility classes like collections and arrays for sorting, searching, and synchronization. For example, using ArrayList, which is string names is equal to new, ArrayList allows dynamic resizing and built-in methods like .add, .remove, or even .contains. The next question is difference between array and ArrayList. Array is a fixed size data structure that can store both primitives and objectives. Its size must be defined at the same time of creation and cannot change later. Example, we have int numbers is equal to new int 5. Whereas ArrayList, a resizable collection class from the collection framework that stores objects only, which is not primitives directly. Its size can grow or shrink dynamically. For example, we have ArrayList of integers list is equal to new ArrayList. In practice, developers prefer ArrayList for flexibility and built-in utility memory like .add, .remove, and .sort. However, arrays are more memory efficient and faster when dealing with fixed size data or primitive data types. For example, in high-performing computing, arrays may be chosen while for generating general-purpose apps. ArrayList is more convenient. The next question is, what is the difference between throw and throws? Throw is used explicitly, throw an exception in a code. Example, we have throw new, which is arithmetic exception, divide by 0 not allowed. Whereas throws declares exceptions, a method may throw, telling a caller to handle them. Example, we have void read file, throws IO exception. In short, throw is used inside a method to raise an exception, while throws is used a method of signature to declare potential exceptions. Together, they help in robust error handling by separating the point of occurrence and declaration. The next question is, what is the difference between final, finally, and finalize? Final is a keyword used to make variables constants, prevent method overriding, or stop class inheritance. For example, we have final int x is equal to 10. Whereas finally is a block of exception handling that always executes regardless of whether an exception occurs. It is commonly used to release resources like closing files or database connections. Then we have finalize, a method defined in object class that is called by garbage collector before reclaiming an object's memory. For example, a finally block ensures a file is closed even if the exception interrupts program. Execution.finalize is rarely used in modern Java because garbage collection is automatic and unpredictable. So the next question is, what is the difference between hash map and hash table? Hash map is not synchronized, which is faster but not thread safe, which allows one null key and multiple null values introduced in Java 1.2. Whereas hash table, which is synchronized, which is thread safe but slower, does not allow null values or values. Legacy class from earlier Java version. For example, we have hash map integer string map is equal to new hash map and map.put 1, Java, and also followed by map.put null key, which works. In modern multi-thread application, concurrent hash map is often preferred over hash table because it provides better performance with thread safety. Checked exceptions occurs at compile time. The compiler forces the programmer to handle them using try catch or declare them with throws. For example, we have IO exception, SQL exceptions. Whereas unchecked exceptions occurs at runtime and are subclasses of runtime exceptions. They don't need to be explicitly handled. Example, we have null pointed exceptions, array in DEX out of bounds exception. For instance, when reading a file, an IO exception must be handled because it depends on external resources. On the other hand, dividing by 0 leads to an arithmetic exception, which is unchecked and typically fixed by better code logic. The next question is, explain the concept of multi-threading in Java. Multi-threading is the ability of Java to execute multiple threads concurrently, allowing programmers to perform tasks simultaneously. A thread is the smallest unit of execution. For example, in a web server, one thread can handle users' requests from another process database queries. In Java, threads can be created by extending the thread, implementing the runnable interface, or even by using executioner service for thread pool management. Multi-threading improves performance responsiveness and CPU utilization, but introduces challenges like synchronization and thread safety. The next question is, what is the difference between string, string builder, and string buffer? String is immutable. Any modification creates a new object. For example, Java plus world creates a new string. Whereas string builder is mutable, not synchronized, but faster, best for single-threaded scenarios. String buffer is mutable and synchronized, but slower due to overhead, best for multi-thread scenarios. For example, we have string buffer sb is equal to new, string buffer hello, and sp.append Java. This modifies existing object. For performance-critical string manipulation, string builder is recommended, while string buffer is safer on concurrent environments. The next question is, what is the difference between abstract class and interfaces? Abstract class can have an abstract and concrete methods. Supports constructors, static methods, and fields used for classes with shared functionality. Whereas interfaces defines only abstract methods, but Java allows 8 plus default and static methods, which supports multiple inheritance. For example, we have abstract class animal, abstract void sound, interface pet, void play. Here the dog can extend animal and implement pet combination both features. Abstract classes are ideal for closely related classes, while interfaces are best for contacts across unrelated classes. The next question is, explain garbage collection in Java. Garbage collection in Java process of automatically freeing memory by deleting objects no longer in use. Unlike languages like C, C++, Java doesn't require manual memory management. The JVM runs GC in the background and reclaims heap memory. Objects become eligible for GC when no active reference exists. Developers can suggest GC with system.gc but not guaranteed. The JVM uses algorithms like mark, sweep, and generational GC, and even G1 collector to optimize memory cleanup. For example, if a student object created in a method is no longer referenced after method execution, the garbage collector, which is the GC, will eventually remove it. This automatic cleanup reduces memory leaks and improves program stability. Now let's move on to advanced level questions. The first one being explain JVM architecture. The Java virtual machine is the core of Java's platform independence. Its architecture consists of several components. The first one being class loader subsystem, which loads .class files bytecode into memory. It includes loaders like Bootstrap extension and application class loaders. The second is runtime data areas. These include the heap which stores objects, method areas, JVM stack, PC register, and even native method stack. The third one is execution engine. Executes bytecode. It includes the interpreter and JIT compiler. The fourth one is the garbage collector, which manages memory by cleaning unused objects from the heap. For example, when you run Java my app, the class loads the bytecode, the JVM executes it, and the GC manages memory automatically. This layered design makes Java portable, secure, and efficient. The second question is, what is the difference between stack and heap memory in Java? Stack memory stores methods, calls, local variables, and references. It follows LIFO, which is last in, first out order, and is fast. Memory allocated and deallocated automatically when the methods are called and exist. Whereas heap memory stores objects and classes instances, it is shared across all threads and is managed by a garbage collector. So for example, here we have int x is equal to 10, which is stored in stack. Student s is equal to new student, which is an object stored in heap. Stack is best for short-lived data, while heap is dynamic object. A common interview follow-up memory leaks often happens in the heap, not in the stack. Let's move on to the next question, which is what is the difference between concurrent hash map and synchronized map? Synchronized map is achieved by wrapping a regular map with synchronization. Only one thread can access the map at a time, which may cause performance bottlenecks. And concurrent hash map provides thread safety by dividing the map into segments. Multi-threads can read and write concurrently to different segments, leading to better performance. For instance, in a multi-threaded server handling thousands of users, concurrent hash map is preferred for scalability, while synchronized map is acceptable in smaller applications with fewer threads. Next, what is the difference between wait and sleep? Wait is defined in object class. It releases lock and pauses the thread until another thread is called notify or notify all. It is used in inter-thread communication. Whereas sleep is defined in thread class, it pauses the thread for specific time but does not release any locks. For example, we have synchronized obj.wait, which releases the lock thread, whereas thread.sleep 1000, which holds the lock. In short, wait is about communication, while sleep is about pausing execution. The next question is explain the volatile keyword in Java. Volatile is a keyword used in multi-threading to ensure visibility of variable updates across threads. Normally, threads may cache variable values locally, but declaring a variable volatile forces all reads or writes to happen directly in main memory. For example, we have volatile boolean flag is equal to true. If one thread change flag to false, another thread will immediately see the updates. Without volatile, they might still read the state cache value. This keyword is critical in avoiding inconsistency in concurrent programming. The next question is what are the design patterns in Java? Design patterns are proven solutions to common software problems. They provide templates to design flexible, reusable, and maintainable code. Java developers often use credential patterns, which is singleton factory builder. And then also structural patterns, which is adapter, decorator, and proxy. And then we have behavioral patterns, which is observes, strategy, and command. For example, the singleton pattern ensures only one instance of a class is created. Using design patterns helps teams follow best practices and improves code readability and scalability. The next question is, what is the difference between callable and runnable? Runnable represents a task that can execute a thread. It does not return a result and cannot throw checked exceptions. Whereas callable, which is similar to runnable but not return a result and throw checked exceptions. For example, we have callable integer task is equal to 5 plus 10 and future integer result is equal to executor dot submit task system.out.print results.get, which prints 15. In real-world scenarios, callable is used when threads need to return results like fetching data for multiple APIs simultaneously. The next question is, what is deadlock in Java? A deadlock occurs when two or more threads are blocked forever, each waiting for resources held by another. For example, we have thread 1 locks object A and waits for object B. Thread 2 locks object B and waits for object A. Both threads wait indefinitely, causing deadlock. Deadlock can be prevented by acquiring locks in a fixed order, using try lock with timeouts, avoiding unnecessary nested locks. In interview discussion, always emphasize prevention strategies. The next question is, explain class loader in Java. A class loader is a part of JVM responsible for dynamical loading in Java classes into memory at runtime. Java uses delegation model where class loading is done in layers. The first layer is Bootstrap class loader, loads core Java classes. The second one is extension class loader, which loads class from extensions. And the third is application class loader, which loads classes from application class path. For example, when you run a program, application class loader loads your classes, while Bootstrap loads built-in ones. Class loaders allows dynamic loading, which is widely used in frameworks like Spring and Hibernate. The last question is, what's the difference between weak hashmap and hashmap? Hashmap uses strong reference for keys. As long as key exists, the object won't be garbage collector. Whereas in weak hashmap, which uses a weak reference for keys, if a key is no longer referenced outside the map, it becomes eligible for garbage collection. For example, we have weak hashmap object string map is equal to new weak hashmap. Object key is equal to new object map dot put, which is key value. And we have key is equal to null, which is eligible for garbage collector. Entry may be removed. Weak hashmap is useful in catching scenarios where keys should not prevent garbage collection. So that's a wrap on this video. Hope this was informative. Do like, share and subscribe to Simplilearn. Keep learning with Simplilearn. Hi there, if you like this video, subscribe to Simplilearn's YouTube channel and click here for similar videos. To nerd up and get certified, you can check the description box below.